This is going to be part 3 of the lab project on messaging. And just to remind you that you probably don't have these lab projects in your manual. But since we did do these lab projects and they were part of the manual at one time, someone might have an older copy and they can use these lectures as a lab wrap-up for those labs. But almost as important is that if you watch these 3 lectures on messaging, you're going to glean quite a bit of information that will assist you in your application. So let's jump right into the last and third session on messaging. Welcome back. Welcome to part 3 of message instructions. This is a lab discussion from volume 1 of the complete PAC Learn series, an introduction to RS5000. In the first section, I remember this is number 3, in the very first section of this lab discussion, we basically added the details from each processor to the other processor's I/O configuration, thus completing an environment for the 2 processors to communicate within. So they're each aware of the other within their hardware configuration. In section 2, we added data structures and we added message instructions. We configured the message instructions so the L35E or PAC L35E could speak to L45, and then we added a message instruction, used the data structures so PAC L45 could speak to L35E. The next section of the lab was called reading instead of listening. You can read and you can write. Writing is basically speaking to the other processor. Reading is not listening to the other processor. Reading is actually going to the other processor and retrieving or taking data directly out of the memory without saying anything to the other processor, so to speak. If you look up here, you see that we have the 2 projects open, the PAC L35E and the PAC L45. I've named these files write read. However, before I started this section of the lab, when I only had write message instructions, I saved it as write only. In other words, this would be PAC underscore L45 underscore write only .acd. This one I saved as write read because I added the read instructions. So when we look here, the only thing that's really new in each of these is you have 2 new tags. Take data from L45 message, take data from L35E message. The L45 is going to take data from the L35E, and the L35E is going to take data from the L45. So I had you create the tags first. That always makes it a little bit easier. Okay, now I want you to open the main routine in each of these. To do that, we just slide it over a little bit and then slide it back. Okay, now I already have the message instructions in there. We'll start with the L35E because that's been our pattern. I'll stretch this out so you can see it better. What I had you do was go to the only instruction that you had in here, rung 0, click there, and then go Control C, come down here, Control V. And so we duplicated that. Then I had you put the tag in here. Now I'm going to delete this third rung because we don't need it. I had you drill down to the new message tag, put it in there, then I had you drag it over here, double click, click at the end of the tag, and put in .en. Okay, and then I had you do the same thing over here. And you could actually click here, Control C, go over here, click here, Control V, and copy this rung over to here, go get the correct tag, take data from L35E message, and then drag it over here and put the .en on the end. So you can see the advantage of doing these side by side. Since both processors are involved in what we're doing, it makes it easier, and it keeps the tag names uniform. So now we're going to open this back up a little bit here. Here's our two message configuration pop-ups. There are two fields that you have to fill out. Of course, you have to select CIP data table read, and then you remember the write instruction, you had a drill down arrow here for the source, but none for the destination. Well, with the write instruction, the source is in the processor that you're writing from, whereas a read instruction, the source is actually in the other processor over here. This source is in the processor over here. The source element for this read instruction is data in memory of the L45, which is over here. And this one is data in memory of the L35E, which is over here. You could easily, I'll cancel this, drag this out, control tags. I could go over here, data in memory, drag my cursor through there, right click, go over here, paste, and then type in bracket 0 bracket on it. That's an easy way to do it. However, the tags were pretty simple, so I just remembered what they were. And then of course these tags, you can drill down and grab them. Data taken from L45, data taken from memory of L35E. Okay, now select the Communications tab, and of course I've already got this finished, but you can browse to find the remote L45 and hit OK, which we did. Browse here, find the L35E, which we did, and then these two tabs are configured, and that's all there is to it. So we click OK and OK, we're configured. You need to save both of your files. File save and file save, and then download both of them. Whoactive, download. I realize that's a little off the screen, but we're always fighting for space here. The bigger we make it so it's easier to see, the more things are going to pop outside. So you can see just enough of this inside the screen capture here to see what we're selecting. And by now you should already know how to do this anyway. Every once in a while when you go to download, it comes back and it gives you a message that something was unable to complete. And this is a resource issue. When that happens, just run the download again. We'll leave it in the program mode, and we'll go over here. Okay, and then we want to download this program. So Communications, Whoactive. Expand the Ethernet driver, and this is the L45. So we're going to the 1768 ENBT. Expand that, goes to the back plane, and there's the processor. Download. Downloading. Okay, we'll change that one to the run mode. And in the meantime, this one went offline because I was gone for a minute. I changed the power supply. So we'll put this one back online. We'll download again just to be safe. Put it in the run mode. Okay, now we want to open up our tag databases, controller tags, monitor tags, and we can expand. expand this set of tags. Okay, now you see we got values in all 4 of them. Let's go back to 0. We want to reset everything back to 0. Data in memory, the L35E, we'll make that 0. And now you see it says 0 over here. Spoken to the L45, we'll make that 0. Now you see it's 0 over here. Data in memory, the L45, 0. Now you see it's 0 over here. Data spoken to memory of L35E, 0. I see it's 0 over here. So now we'll reset back to 0. The one that we already tested in the previous section of the lab was data spoken to. We'll put something back in here. There it pops in. Listen to data from L35E. Then we have data in the memory of the L35E. We'll put something in there. And now you see the read instruction over here reads it out of the data in the memory of the L35E. What we have left is we want to speak to the L35E, so we'll put something in here. Now we clean that up, and then data in the memory of the L45. So right now, data taken from memory of L45. The read instruction right now is reading, but it's reading a 0. You're getting a 0 at the L35E. We put a value in here. See, now it's reading in over here. So this really completes two-way conversation. We have data to speak, and then we know where to listen to data from the other processor. Okay, here we are in the next section of the lab, and we titled this Pack L45 Write to Uncle Micro 1100 who lives in RS500 land. In order to do this lab, we had to have something in RS500 land. I had you create a program, and I'll bring that up. And there was a couple rungs that you had to create in RS500. Now you see I'm using RSLogix 500 Pro. You might be using MicroStarter Lite and doing this in a 1000, or you could do it in 1100. But looking at the logic that we have, the primary rung is this rung right here. And whenever you see a timer done bit examine off like this, going to a timer, and you see that they're not the same timer data structure, this is T41 and that's T40, then you know that some other timer is controlling the start and reset of this timer. If you look right below, there's T41. When T41 is done, this whole run goes false and it starts over again. First scan through, this instruction is true because T41 hasn't started timing yet, so it can't be done. We start T40, that's going to run for, in this case, 2 seconds. When it's done, then it's going to start T41, and T41 is going to run for 2 seconds. And when it's done, this is false. Both these timer instructions are reset, and it starts over again. Now the rest of this rung and the last rung are instructions that control the 4 outputs: output 0, output 1, output 2, and output 3. There's nothing relevant about this logic other than it is something dynamic in a Micro 1100 that we are going to intervene with from message instructions in the CompactLogix processor. If we were to let this run, and I will put this in the run mode now, you can probably hear the relay outputs clicking in the background. If you listen close, you can hear the relays energizing and de-energizing in time with the screen changes. So you can see this timer runs up to 2 seconds, it's done, and this one runs up to 2 seconds, and it's done, and it starts over. During that interval, the whole time that T40 is timing, down here the very last rung, it's going to turn on output 0. When the accumulate value, this value right here for T40, T41, so T40 accumulate value, when it's between 25 and 100, output 1 will come on. When it's between 75 and 150, output 2 will come on. Between 125 and 175, output 3. And of course, output 0 is on the whole time any of these are on. This is just a very simple little spatter of logic that's dynamic, and we can affect the timing with the message instructions. And then the first rung, if we have enabled remote control of the data, meaning that we want to move values from the message instructions into the preset values here, they're both set at 200 right now. So if we look at the first rung, here we're moving N70 into the preset for T40, and then here we're moving N71 into the preset for T41. So reading this logic, if we have enabled the remote control and N70 is less than 200, then move 200 into N70. So this little piece of logic here limits the minimum of N70 to 2 seconds. So if you try to put in something less than 2 seconds, this is going to override and put in 200. Otherwise, it's going to move N70 into the preset for the timer, and then we're also taking the accumulate value from that timer data structure and moving it into N711 that we're going to have access to from the MicroLogix controller. And then this is a repeat of the first 3 branches, only it's N71. Again, we're limiting the minimum to 200. N71 is moved into the preset for T41, and then T41 accumulate is moved to N712. We're going to work with integer files N70, 1 and 2, and then N711, 12 and 13. Now, looks like we're only going to use 0 and 1, 11 and 12, but we up here see we have N713, so we could do something with N713 directly from the MicroLogix controller. We can add logic to turn this on and off from the other controller. So I'm going to put this back in the program mode so we don't have to listen to it. We'll minimize this logic and we'll go to our MicroLogix pack L45. After I had you create the program in the Micro 1100, then I had you go to the controller tags right here, go to the Edit Tags tab, and then I had you take and select 2 tags and then copy them and paste them down below. We're going to go to data spoken to memory and data taken from memory. We're going to put the mouse right here, hold it down, drag it down so we've selected both. Then we're going to go Control C, go down here, select that last row, Control V. Now notice that it pasted them in there, duplicates, but it did change the text. It changed it to a 1 because you can't have 2 tags with the exact same name. So we're going to edit our tags here, and we're going to make that micro. Instead of L35. And then we're going to go to the end here and put that back to 0, 0. Okay, what that does is that gives us 2 new data tags. Okay, now I'm going to double click, I'm going to click here a couple times to get the data tags up here. We still got the message tags down here. I just put them, I flipped the order to get them back into alphabetical order. Now these 2 tags, then we want to copy these. So we hold the mouse down here, drag it down 1, let go, Control C, select here, Control V. Okay, we want to change this. Notice this time it didn't increment it by 1, it just added 1 to the end of it. So an interesting variation. Oh, I tried to save it and I can't because we already have that tag up here. I have to change it to micro. As long as they're different and you know what they're for. And so I'm going to go down here and get rid of that 1 on the end. That's close enough there. I might have had an extra underscore, speak to underscore micro message, take data from underscore micro message. The actual names don't matter as long as they're unique. Okay, so now I've created 4 new tags. 2 message instruction tags and 2 data tags. Now we're going to add a new rung in our logic. I can close the controller tag database, go to the main routine, and since these are both, one's a write and the other's a read, I could just take and copy these both and then edit them, but instead I think I'll just do it the easy way. Create a new rung, go up here to the ASCII entry and type in XIO space MSG. Enter. And I can do that again. Type in XIO space MSG. Enter. So now I want to create 2 message instructions, one to write to the micro and the other to read from the micro. The first one we did was speak to micro message. We go here and we go pick the speak to micro message. Then we can take and drag this. Remember, we already created this tag, so we can just go ahead and use it. Makes it a little simpler. Type in .en, and of course you remember that this instruction is here, so we don't enable this message instruction to execute again before it's finished. So once we enable it, that message instruction will not get enabled again until the enable is turned off and this goes true. So this is true if off. As long as the enable is on, then it'll go on the very first scan and it'll stay on until it's finished. Then it can re-enable and send the message again. Down here, we're going to use the take data from micro message. That'll be a read. Drag the tag over here. Add .en to the end. And now we've got our 2 message instructions in rungs. However, that does not configure them. So our write, we want a slick typed write. And we want data spoken to the memory of the micro. So we could go select the tag here, or we can just, since we've stuck to the same format, we know all we have to do is change the name of the target device. So, and I could type in MICRO, and the minute that it represents a tag that already exists, notice the rest of it goes reverse video, and the micro, even though I typed it in lowercase m, is now uppercase m. If you know for sure what the tag is, just start typing in the correction, and the instant it recognizes, it'll take this shape. So we can hit enter. Oh, well, I actually, if you hit enter before you finish the whole configuration, it's going to give you that message. So let me do that again. Failed to save configuration for tag blah blah blah, invalid remote element for select message type. Well, that's because we're not done filling this in. So the destination element is going to be N70. N7:0, length of 1. Actually, we're going to use 3. We're going to need 3. We only, I think, technically need 2. And I think we extended the tags out to be arrays of 10 elements just to add some spice. Now we're going to go to the communication and type in the path. We've done the configuration, SLC typed write, The source element is a tag in this controller, in pack L45. A length of 3, see we have here element 0, the first element, so we're going to need 0, 1, and 2, length of 3, and we're going to N7 0. Now in the other controller, I think we have N7 0 through 99. So we have 100 elements in that array of N7. So we've got plenty of room to send the data to. Go to communications. In this case, you can't browse to find the controller because that controller is not a Logix engine. It's not part of that environment. So we type in 1, comma, space 1, comma, space 2, comma, space, and then the IP address 192.168.1.112. Remember that we're going from the L45 and we're going to the backplane. The backplane port is always 1. Then we're going to slot 1, which is the ENBT, and then we're going out the front of the ENBT, which is 2, and then we're going by Ethernet to 192.168.1.112. And that was all explained in the lab manual. So now we can apply this, and we have the write instruction. Now we're going to go to the read instruction, do the same thing. We do a SLC typed read. The source element is N711. Length of 3, and this is going to be saved destination element, data taken from memory of micro. Go to the communications tab, and we still have the same path. 1, comma, that goes from the L45 to the backplane, space 1, comma, that goes over to slot 1 of the 1768 bus, which is the ENBT, the Ethernet card. That goes into the card. So 1, 1 gets us out of the L45 over to slot 1 of the 68 bus, the passive bus, and into the 1768 ENBT. And then 2 gets us out the front of the ENBT, which is the Ethernet port. And once we're out on Ethernet, we want to go to 192.168.1.112. Okay, here we had save your project and go online with the L45 and the micro side by side. Downloading. Change the remote run mode. Now if we haven't made any mistakes, and by the way, just for grins, if you open up the message instructions, you can usually see errors down here. If you go to communication, it may also show errors, but this is pretty much your spot down here to look for enable waiting, start, done, and done length is something that you seldom will look at. But remember that this is executing so fast that you don't see anything but enable. Looks like it's always enabled. Okay, and you can do the same thing with all these instructions. You can go look to see if there's any errors. Okay, now we're going to get rid of the logic and open up the controller tags, and we want to monitor the tags. So we want to expand data taken from micro and data spoken to the memory of the micro. And I see there's already values in there. So now we'll bring up the MicroLogix 1100, go to N7, lock it on top. So everything's in view here. I'm going to move this out of the way. So here's N70 through N7, well I said 99, it looks like it's 104. So there's 105 elements in that. And now I'm wondering if I expanded the arrays in CompactLogix. So we'll go to controller tags, edit tags, and we'll drag this out. No, see, I didn't do that. Also they need to be ints. So file, save, go offline, and then data spoken to memory of micro, edit, properties, and we're going to make this a integer, so I could just delete the D, and I want to expand it out to 10 elements. And I'm going to go to this tag, right click. Actually, I can probably get away with doing it right here. Delete the D, and then a 0, and it's done. I'm going to save that. And then download. The reason that it needed to be integers and not double integers is that the RS500 arena deals strictly in 16-bit. So we don't want to be moving 32-bit words into a 16-bit environment. We might get away with some of that a little bit, but we would be, if we did, we would be overlapping in memory. I just went back and cleaned it up here. So in the lab I had to do arrays of integers of 10. I just didn't do it here when I was online. And I really sat and debated for an instant whether to back all the way up, start over, or just show you how to correct that error. But notice I did it offline. You can't edit tags at that level online. I saved, went offline, made the changes, saved, and downloaded. Now we'll go back to monitor tags. We'll expand the 2 tags that we're dealing with the micro. Now you see there's 10 each. And see, we have a value in the second integer. So it's a good thing that we expanded them. Now we'll go back over to 500 land. I'm sorry, yeah, 500 land. Yeah, those might be remnants from something else we were doing. Data spoken to memory, I've got a 1212 in there. And if I were to enable the remote control, remember we're in the remote program mode. I'm going to make this 190. And I'm going to make, here's where we put the other preset, we'll make that 195. And if you look over here, see 195 and 190. Now, watch what happens to N70 and N71 when we enable the remote control. And then put this in the run mode. So you changed them both to 200. However, if we had made them 260 and 205, so now it's 260 and 205. We are writing these 3 integers over to the SLC 500, and then we're reading these back. So what you see reading back here is the accumulate value. And we did ask a few questions in the lab. Mainly we had you set the presets, or I should say N70 and N71 below 200, and then see what happens. And then we had to increase it above 200 to see that it actually took the values. So anything above 200 it accepts, Anything below 200, it does not accept. And then we said we had you add a rung to enable N713.0. So we'll go back here and we're going to add a rung. I got rid of the tabbed instruction set, so I'm going to have to bring that back. I'm going to close this, bring a rung down, a true-if-on and an XI and an OTE. Whoops. And we'll make this N72/0. And then this will be N713.0, of course. We'll accept, test, and assemble. Now I can enable this bit from in the compact logic. So as N72 would be the third word in the first bit. So if I make this 1, hit enter, come back here, notice that that's now true. And just for grins, I could make this 3. And that's going to stay on because binary for 3 is bit 0 and bit 1. So as long as you pick a value here that turns on the first bit, like 7 would be the next one. So you can see it's still on. However, if we picked 8, then it'll be off because the binary for 8 is working from least significant bit, which is to the right, and going left would be 0, 0, 1. So no 1s, no 2s, no 4s, 8. Well, actually the fourth bit, or bit 3, would be on. The first 3 bits would be off. If I go one more here, make this 9, then that bit is going to go back on. But just to keep things simple, we only want to turn on that 1 bit. So in other words, we're controlling the logic in the SLC500 arena, which is the MicroLogix 1100. We're controlling it from a bit here in the compact logics. That concludes part 3 of the lab discussion on the message instructions. Thank you for watching.